Good morning, everybody. I have to say that all my presentation is completely outdated. Sorry for this. Yesterday evening, very late in the evening, I got the greatest news that finally the Commission has published the proposal for the CHIPS Act 2.0 that now has to be blessed by the Council and the different countries and then put into translation to legislation, but now it's here. So, and then also I got the presentation from Ariane very, very late yesterday night. So I said, well, what do I do now? Should I throw out, my presentation and cancel it, or what should I do? Okay, so I decided to continue, and what I will do is to focus more on the issues and the opportunities. Because I think after what Ariane has told us about, how it's going to look like the CHIPS Act 2.0, there is not much more I could add. In November last year, I was asked by the EU to chair the Industry Advisory Board. By the way, some of my mates on crime, I would say, are here. So Nokia, Global Foundries, Infineon, OpenChip will be here today as well. OpenChip didn't arrive yet, I believe, but the rest are already here. So it was quite interesting because this group was formed of 16 companies covering the whole value chain, from materials and tools. ASML and ASN were part of it, up to the end users. So Nokia, Valeo, and Thales were also part of it. And in the middle, we had foundries, Global Foundries and TSMC. We have IDMs, which are the incumbent, I will say, today in Europe, and then some startups. The issue was putting together all the wishes from all the different parties. As you can imagine, very different wishes and needs from startups that are more focused on AI and therefore on leading-edge technologies, and with the IDMs, which are today supporting primarily automotive and industrial segments, and therefore they are more focused on mature and advanced technologies, but not leading edge. So putting together both of them was not an easy job. However, I have to say we succeeded, right? And we were able to present to Henna Virkkunen the final report about 1 month ago, a couple of months ago. So let me go through what I believe are the issues and opportunities. Well, I don't think I have to tell you, because it's very well known, that all the digitalization goes around semiconductors. By the way, Susanna, let me correct you on one thing. Please don't say microchips, because today they are nanochips. Okay. You can say chips or semiconductors, but not microchips. But anyway. So all digitalization goes around semiconductors, is based on semiconductors, to the point that the semiconductor industry in the last 10 years have moved to the top 3 most profitable industries in average of the world, reaching last year 800 billion, American billion, US dollars. However, there are 2 main now things that are changing the whole landscape of semiconductors. One is artificial intelligence and the acceleration of the industry that AI is really bringing. And the second one is the geopolitical issues, because semiconductors now is the key negotiation weapon that is being used. If you saw, a couple of weeks ago, Trump was meeting Xi in China, right? Who did I bring with him? He brought Tim Cook, he brought Elon Musk, and Jensen Huang from NVIDIA, showing that this is really the key negotiation weapon. semiconductors and microelectronics. What she told Trump, be careful with Taiwan. Why? Taiwan today is the largest producer of advanced chips of the world. Although Trump already has made sure that TSMC is now moving big way to Arizona, 6 fabs committed in Arizona. So, but still Taiwan is critical. So China is saying, yes, Ariane, yes, it's very important because of the Sea of China, the channel, but it's also very important for Taiwan, because of semiconductors, especially leading edge for AI. Actually, if she is now avoiding Jensen, NVIDIA, to sell advanced chips to China, is really hurting China for their build-up of AI. By the way, China is saying, or Huawei is saying, no, we will have Armstrong. I think that they are saying that they will have 14 Armstrong or something like this in a few years. Well, I am asking always ASML, are you really able to ship high NA EUV, which is the most advanced EUV really required to build sub-nanometer wafers? And ASML is saying, no, we cannot. So do you think China could really copy those machines? Say, well, not now. So what is happening is that China, in order to produce sub-nanometer chips, they have to do multiple patterning. This means probably, I don't know, 1 year cycle time. What do you think, James? 1 year or something like this? So this is impossible. Anyway, so let me touch on the first really opportunity, AI. So last year, I said already that, and someone also said, that the overall semiconductor was about 800 billion. Now, this year is going to be 1 trillion. $1 trillion US. So the whole thing is getting really accelerated. If you see in the graph, the big acceleration is unbelievable, because the PC, the internet, the smartphone eras really brought a huge growth in semiconductors. But what is happening now with AI is going to be really a key revolution that we cannot miss, we shouldn't miss. Okay, Ariane also in somehow showed this. What I am trying to show here is the growth in semiconductors is coming primarily from leading edge technologies. Mature and advanced are really having a quite, I would say, minimum growth. You can see here on advanced and mature is growing 3%, while leading edge is really between 22 and 14 for the memory. 3 pillars. I am not going to repeat that, don't worry. What I would say is, the issues in my opinion. On the pillar 1, R&D. So far, it was much more focused on research excellence, and not too much trying to link the research into industrial effect. So, and what we really need is, we have leaders in R&D, IMEC, Fraunhofer, Leti, CEI, Leti. They are really leaders in R&D. We really need this to convert into industrial, into revenues, into real business. On R&D, on manufacturing, I think Ariane covered what I said at IMEC last week. We have to build the roof. No, we have to build the house, not from the roof, but from the basement. And the basement is design. And Ariane covered this very well. So, what is happening in Europe? Well, the CHIPS Act 1.0, the final aim was to reach 20% Europe market share of semiconductors. Because at the beginning of the century, this is where we were. We were at about almost 25%. if you look at where are we now, probably we are going to reach only 6% share. We absolutely need to change this. And the way of changing this is moving more into where the growth is. And I will try to cover this. So again, why ECA? Because 2.0, because we really need to change this. We really need to avoid the stagnation that the European semiconductor industry is now facing. And therefore, we are trying to address the shortcomings of the ECA 1.0. So, again, I am not going to repeat. On R&D, what we want is to link the R&D, the research excellence, to industrial engagement and industrial impact. And we want to also focus on the whole value chain, on the whole ecosystem. Ariane said this very well. From design, from the chip design to the final end user, to the final product. We really need to address this. And by the way, let's be clear. We have all the things we need in Europe to address it. We are for almost 450 million people. We have good education. We have good system that makes Europe a great place to work and to live. We have all the ingredients. We just really need to work hard and in order to, and have the ambition to reach what we really need. Now, we are leaders in some areas which are going to be also critical in AI. Because AI, what we know today primarily is the generative AI, the ChatGPT and DeepSeek or whatever you want to call it, right? However, we are now, AI now is moving to agentic, which means that the AI is going to start taking initiatives by themselves, once they are being trained properly. And then the next step is going to be the physical AI. Physical AI means that where we are leaders, sensors, actuators, microcontrollers, all of this will be really required to be used in physical AI. So the opportunity here is to link both our current strengths, and we really need to strengthen our current strengths with the new AI, and therefore we also need to support the startups that are really having a good solutions already for AI, especially for inference. Again, I think this is much worse foil than what Ariane has been showing us, but what I want again is we really need to link to move the demand to industrial engagement and industrial commitment. So therefore, we have to focus on ecosystem. We have to focus on the whole value chain. So expanding first of a kind, including everything. Timo, this is important for you, important for Nokia. We really want to have Nokia also as part of first of a kind. We really need Nokia and Ericsson to be the leaders again on 6G. Nokia has been, and Ericsson have been the leaders in the previous G. Now we really need to come back and be leaders on 6G. Again, R&D, industrial acceleration. EU dedicated budget. I know this is going to be tricky, but we need minimum 70 billion euros in order to fund everything we need, everything what you have said. Reduce bureaucracy and simplify regulation. This is critical. I mean, I know we are losing now projects, investments in Europe and also in Spain because the regulation and the speed is awful. We really need to solve this. And finally, talent and skills, improve mobility. We have good talent in Valencia. It's okay if they go to Dresden for a while because they will come back. In Dresden, there is now, good foundries and good Infineon and Bosch and so on and so forth, very good companies. It's okay. It's okay. We really need mobility. We really need to move the people where it's needed. By the way, IMEC is building now a good innovation center as well in Malaga. Malaga has not enough talent. This is an opportunity also for the Valencia University, but we really need to address mobility. So, let me again get back to the real opportunity. Of course, this I stole this from Kevin Sang from TSMC, and this is why the starting point is Foundry. So Foundry, by 2030, Foundry as a whole will be about $500 billion. The whole semiconductor will be $1.5 trillion US dollars. Electronics, in general, could be $4 trillion, IT, $15 trillion. The global GDP, based on semiconductors, because all the innovation that semiconductors is going to create will be about $150 trillion. By the way, be aware that the actual worldwide GDP is less than $125 trillion. We are forecasting $150 trillion. So the opportunity is there. Valencia has to make it, and of course, Europe has to make it. We have all the ingredients to make it happen. Thank you.